Find the equation of the tangent line for f of x equals 4x divided by x minus 2 squared at the point x equals to 4. For the equation of the tangent line, we need the x and y coordinates of the point. Right now we have just the x coordinate. So the first thing we need to do is find the corresponding y coordinate by plugging that x coordinate into our function, which is 4x divided by x minus 2 squared. So our y coordinate will be f of 4, plugging the x coordinate in, and it'll be 4 times 4 divided by 4 minus 2 squared. 4 times 4 is a 16, 4 minus 2 is a 2 squared, so we have 16 divided by 4, which comes out to 4. So we have an x coordinate of 4, and it turns out we have a corresponding y coordinate that's also a 4. So the point is 4, 4. Now that we have the x and y coordinates of the point, the next thing we need is the slope of the tangent line, and that is the derivative. So now we're going to evaluate the derivative of f of x. Well, our f of x here is a quotient, and therefore it's going to make use of the quotient rule for the derivative. So f prime of x will be the derivative of the numerator, which will be a 4, times the denominator left alone, x minus 2 squared, minus the numerator left alone, 4x, times the derivative of the denominator. That'll be a power rule to start things off. We bring down the 2 for the x minus 2. We leave it alone, subtract 1 from the power, and then multiply by the derivative of the inside to complete the chain rule. And then we have this all over the denominator squared. So the first term we're going to leave as is. There's no simplifying needed. For that second term, I'm going to multiply the 4, that 2, and that 1 together. 4 times 2 is 8, times the 1 is still an 8. So we have minus 8. We have an x, and then we have an x minus 2. And then the denominator, x minus 2 raised to the 2 and raised again, you multiply those exponents 2 times 2, and that'll give us the power of 4. Now you can go further and factor out an x minus 2 in the numerator and cancel the denominator and simplify this a little bit more, but because we're going to be evaluating it to get the slope, we can just leave it like this. And the slope will be evaluating the derivative at our specific x coordinate, which is a 4. So the slope will be f prime of 4. Let's plug a 4 into the derivative. And that will give me 4 times 4 minus 2 squared minus 8 times 4 times 4 minus 2 all over 4 minus 2 to the 4th. So this will be 4 times 4 minus 2 is a 2, so 4 times 2 squared minus 8 times 4 times a 2. And then 4 minus 2 is 2 to the 4th. So our slope, f prime of 4, will be 4 times 2 squared. Well, 2 squared is a 4, minus 8 times 4 is a 32, times a 2 is a 64. And then 2 to the 4th is 2 times 2 times another 2 times one more 2. That gives us 16. So we have 16 minus 64 over 16. Well, 16 minus 64 is a negative 48 over 16. And 48 is divisible by 16, giving us a negative 3. So there's our slope. We have a slope of negative 3, and we have our point of 4 comma 4. We can now set up the equation of our tangent line using the point-slope formula. Y minus the y coordinate of the point, that's a 4, equals the slope, negative 3, times x minus the x coordinate of the point, which is a 4 as well. There's our point-slope formula. We want to put this in the slope-intercept form, which means solve for y. That's how it's usually found for the equation of the tangent line. And that's done by distributing the negative 3 in. That'll give us a negative 3x, and then a positive 12. and then adding 4 to both sides, and that'll be a negative 3x plus 16. There's the equation of the tangent line to that function f of x at that point, x equals 4.